So welcome everyone. We are going to speak about HTTP 2. So I'm Quentin ADAM. I'm the CEO of a company called Clever Cloud, and basically works on Twitter. And this is my day-to-day job. My day-to-day job is taking care of your application because what we do at Clever Cloud is keep your application online. In fact, you can write your application in most of the platform you can imagine, and just git push on top of Clever Cloud, and it will be working because we restart it if it fails, we adjust the resources you need, we manage all the security fix, we redeploy without downtime. It's basically like we provide you application working. And for this, we have customers everywhere in the world, and thousands of customers, and we see a lot of applications. So there is plenty of people using Clever Cloud with PHP, Node.js, Java, and we see how they work, and we learn what is a good practice, what is not, and we feedback them to the community. So this is why we give a lot of talks. So basically, this is what we do. And we're working a lot of HTTP because everybody today is working on the majority of internet stacks. So basically, what is the HTTP job? HTTP is all the requests on the web. Every time you're using a browser, an API, something like this, you are hitting HTTP as a protocol. And it's a long-term protocol. It's been using for 20 years now, and it's still on version 1, and it's a text protocol. So basically, you can request this HTTP with just using telnet. It's a layer AT, and it's a port AT, and you can using it. It's a text protocol. It's all based on a request-response model. So you ask for something, and the server gives you back an answer. And there is no way you can do another thing, like push, all this kind of stuff. It's not like this. It's just, I ask for resources, and I give you back resources. At the beginning, the meaning of HTTP was resources. And this is why there is 4 parts. The first part is a verb, what I want to do, get, put, post, delete, or anyone else you want to do. There is why it's extendable. For example, there is a people of WebDAV making all file systems on top of HTTP. So you can extend the verb. There is the resources you are eating. So it's a path, something slash something slash something slash. And there is the headers, who provide you the context of the request, and optionally a body. Because if you are wanting to put something, you need to give a body to the thing. And what is interesting with these specs is it's made of option. So there is a lot of ability to extend. It's cute. The thing is, quite interesting is, if it's around for 20 years, there is a reason. It's easy to use. It's easy to build a pattern. It's easy to build things like that. But the thing is there. The web is faster and faster and faster. And we all need faster answers to our request. Because today we know at eShop that just a little bit of time, a little bit lack of time, make you lose a lot of money. So basically, we need faster and faster and faster system. And we try to put a lot of requests on our browser. This is the evolution of requests, number of requests and request size. This is the way, the green, the dark green is the size of the request average on big website on the planet, and this is the average number of requests per page. So I remember once, I'm so sorry, I remember once when I started to work on the internet field, we have only 3-4 requests per page and 2 kilobytes. But it's no more this time. we have huge load on web page, and yeah, mainly we use a lot of assets on the web page, and this is a problem. Because with HTTP, we have something called the pipelining. The pipelining is basically, if I ask for something, I have to wait, I have the answer. And this is a problem. So basically, today, we're using a lot of hacks. And we don't think all, but we're using a lot of hacks every day to manage it. First, we know with pipelining, we have the problem of the number of the connection between the browser and the server. So, no problem. We will using a lot of streams to manage that. So, we use several domain names to open several sockets to servers and get back the field. So basically, when you're doing that, there is 20 or 30 requests open to multiple servers just to load your web page. We're using a lot of domain names just to manage, for example, static thing. We have only one domain name, this is your web page. We're using only one domain name. Okay, who is using CDN? For content delivery network, and who is using crappy thing like d1.statics.mydomainname.com? Yeah, this is the point. We need to open more connection to the server because the HTTP pipelining retains the information. And there is another thing, cookies. Like huge fat cookies with a lot of data inside it. And each time I ask for something, I know, I ask for about 19 files to the same server, but each time I have, oh, hi server, I'm basically Firefox, but I'm also Chrome and Internet Explorer because I don't want to be filtered on my client name. I speak mainly English, but I can also speak French, Japanese, or whatever you want. I prefer to have XML, but if you have HTML, it's fine. This is the diet I am, and this is a fat huge cookie you give to me before. And sometimes you get some fancy information in the cookie because some developer thinks the cookie thing is something that is only on the server side. So sometimes you find the password of the database inside the cookie. You find like all the ACL system of the user. Nobody. I've seen website with cookie of 2 megabytes. Okay, guys. I give you 2 megabytes for getting a 10 kilobyte file of a dot in a GIF. So, cookies. And each time we ask for the server, we're giving them the all new, the old headers I say to them like 20 times before. It's totally stupid. But this is why HTML requests are never linked between them. So this is a problem. The other hack we do is all the commit, WebSocket, pooling, server, blah, 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 bidirectional data stream hack. Who is doing a commit system? WebSocket? Who is happy with WebSocket? Oh, fine. You're kind of BDSM guy? No, but the thing is, server-sent events, this kind of thing, we all know what is this kind of hack we do for this. But the protocol was not built for this at the beginning. And we put a lot of hacks around that to managing it. So basically, we all need a new version of HTTP. There is a federation in charge of that. There's a non-profit called the IETF and is in charge of managing the HTTP protocol. And okay, basically everybody was saying, okay, we need a new version of HTTP protocol. Hey, we are Google, we build PDI, things like that. And IETF thought, no, it's too complicated to make HTTP protocol. Yeah, but we're launching PDI too now. So basically they were like a little bit forced to working on an HTTP working group. The HTTP working group have the hard mission to get a new version of HTTP. And the pressure was so hard, so basically they say, okay, we have to build on someone already works. So basically, HTTP2 first draft was a search and replace from the working draft of Speedy 3 from Google, which is basically a good news because Speedy is a good protocol and they've experience and everybody was thinking, okay, just take Speedy 3 and making a new version of HTTP based on this reflection. And almost everyone was on the working group. So major browser, major server implementation, and a lot of people were on the working group of what is going on with HTTP2. So what's in the box of HTTP2? First news, HTTP2 is a binary protocol. Okay, I know. Every developer are standing to, yeah, but we love our text protocol, which is HTTP1. This is a text protocol, it's easy. I have just a question. What is the last time you have opened a HTTP request using Telnet? Who is doing this month? This year. Okay. The thing is, HTTP1 is no more a text protocol. We all using compression and SSL layer on top of the thing. So basically, it's kind of binary. We never look at the inside of an HTTP1 connection. There is plenty of cipher around that. We hide the data from us. And the other thing about binary protocol, it's they are safer. Because passing passing text protocol was a little bit complicated. It's a lot easier to pass a binary protocol because you are more free, and it's a lot concise. It's very more shorter to think. Who have done a parser for multi-part HTTP thing one day? Do you have ever read what is the data inside a multi-part request? I have to say to you, it's ugly. Because the thing is define a binary in a text protocol, it's quite complicated. It's very simple to do in a binary protocol. You just say, this is the way we define a frame. And you cannot do that in a text protocol. So basically, I think it was a good idea. So, the decision of making HTTP2 a binary protocol led to another decision. One of the first members of the new working group was the people of Wireshark. Who know Wireshark? Okay, cool. Who have Wireshark installed in this laptop? Most cool of this is Wireshark is one of the first member of the working group, and they're working closely to have a very good support of HTTP2. In fact, they do some amendments inside the HTTP2 draft to have a better version for intermediary role inside a relationship between a request and the server. So for the people who don't know Wireshark, what is Wireshark? Wireshark is something we are able to say to the system, I want to see everything is going to the network card. So basically, your app will show will show all the things to Wireshark. If you're using Wireshark, we are able to see all is going on your network cards, and he is able to say, okay, we'll unpack the compression, unpack the security encryption, other thing like that, to just show you the data we are actually translating in your network card. So basically, using Wireshark is a very good idea when you are debugging your application. It's a very cool logic and very cool thing, and it's pretty usable because you can add a filter on almost everything there. So basically, this is how we will handling the binary of the protocol. The other thing is HTTP2 just open one TCP connection between the client and the server. Why? Because it's more easy to just manage one connection and decide what we will build on this connection. There is only one connection, we know it, and we can manage priority and things like that. I will describe it just later. And in just one TCP connection, we can put some streams. So you have one connection, you put some streams inside this connection. And basically, a streams is an HTTP 1 request. So inside the connection, you have some streams. And the streams are built of frames. Frames are a piece of data. So you have a connection, one TCP connection with multiple streams inside it, and each stream is built of frames, depends of when the data is available to be forwarded to the client. This is how it works. You can have streams with the first frame of a.html, then a first frame of doc.gif, then your hard drive gives you the next bunch of data of the HTML file, so you give them back to the network card to be the next frame of the stream a.html. And everything is like this. What is interesting is, at the time of your server is able to have the data it can forward to the client, you give them to the client. The problem is when you are taking one connection, waiting for the server to give all the data, is sometimes the server have lack of time getting the data. For example, if it's a big picture, the big picture is on a hard drive. A hard drive is slow. And if the big picture is not in memory, he have to read it from the hard drive. So if you just putting the big picture data inside the connection is not usable all the time, and you are waiting for open a new connection about another file for this. So this is quite interesting because you can manage several sending from the server to the client each time you have data ready, which is cool. And the binary goodness is framing is quite easy to pass. So this is why it's interesting. This is a framing made with binary. It's more simple, you see. It's easy to see the piece and bunch of data. Which is interesting is we have stream priority on this. The stream priority is to saying the HTML file has to be given to the browser very quickly because you need all the HTML file to have the rendering. And this image file is the logo of the company. It's pretty interesting too, so we give it fast. The JavaScript is the most important thing because we know all the JavaScript will be slow. So basically, what the server does is just giving the data to the browser at the right way to be sure the waterfall of the browser will be optimized. So this is quite interesting, in fact, because what is happening is we're giving to the browser the data as we get it. For example, we can give to the browser a small picture, crappy quality picture of the background first, then give them all the other thing, and give it the big picture with huge quality of the background next. Because we know what is going on the pipeline, because we know there is only one connection, and the server will be able to determine what is the quality of the transmission between the client and the server, and optimize data flow inside it. Did you get what I say? It's a pretty good GIF, I know. Basically, what is cool is never before we can optimize really the connection between the client and the server. And it was really bad, because the problem is if you don't know what is really the ability and the quality of the transmission between the server and the client, so what is the bit rate of the transmission, you cannot optimize it. With only one connection, I am able to just put data inside the connection at the huge quality speed as I can. So I can, as a server, say, okay, we have 20 kilobyte transmission quality between our two systems. So I know I can put you the HTML file at this speed, which is we cannot know before because we open it like a lot of TCP connections, so we don't know who is who. And it was complicated to manage this in this way. So this is quite cool because we can do a lot of things on top of that. We can provide picture at the good speed, at the good quality. We can adapt the quality of a picture as we send the data to the browser. We can imagine things like if you are on a poor mobile quality network, we can send you only very low quality picture from the website, but the speed and the reactivity of the browser on the mobile will be improved by thousands of times because you only get the data you can have with this kind of connection quality. The other thing about that, and it's so cool, is I know what I have to give to the clients all the time, and I have a connection. So I give you all the home page of my website, and as a server, I say, okay, cool, I have a connection with the client, and I give it all the home page assets, quality, and all the things he has requested to me, I give him. So I have nothing to put on the connection. We all know that 30% of the people who are stuck in their home page are just clicking on that link, which lead to this another page. What we can do is just push them the data of the second page to pre-populate the cache of the browser. So this is quite interesting because we give to the browser the data it will be needed next. So in fact, it's a huge quality assets because when the user click on the second page, he has all the picture, all the JavaScript, all the CSS in the cache of the browser. So in fact, it's just instant. Because if you click, you have the data. And the user experience is far better than that because it's no longer waiting for the data. Sure, you can, as a client, saying, I don't want pre-population of the cache. I don't want cache data. But it's quite interesting when you are a browser because you can get all the data of the website silently when you are just reading the first blog, for example. If I know all the people reading that blog will click on this link, I can give you the rest of the website. This is quite cool. Yeah. The browser don't know how it will work later. He only gets new file and it stores it in the cache saying, okay, maybe I will need it sometimes. Yeah, the ability of managing cache of the browser will be a lot more intelligent and smart on the time, yeah. It's a lot of new possibility we open right now, yeah, sure. The other thing about that is the header compression. Header was a huge thing with a lot of lack of security problem. Did you heard about the problem, the security problem of WebSocket? WebSockets are basically cross-origin compatible from the beginning. If you do the authentication on WebSocket just based on a cookie, I can open a WebSocket on a, basically, imagine you have a WebSocket on twitter.com giving you the ability to post new tweets, and it's based on the cookie of twitter.com authentication. I am on one of my non-twitter.com website, and I just say to the browser, I open a new WebSocket with twitter.com. It will use the cookie, because it's twitter.com, to open the WebSocket connection. And I'm authenticated at twitter.com with a JavaScript coming from non-twitter.com, and I can post tweets behind you without you knowing anything, because you are giving back your authentication, which is a huge lack of security coming from the headers and all this stack around that, because we are not thinking to permanent connection. So this is why there is a lot of work doing on headers. The thing you have to understand about headers is it's all new format, a whole new request for comment, so it's a new standard called hashpack. Hashpack is a totally brand new way to put data from header. It's more compressed, it's more securized, it's more interesting. And the other thing is there is a header persistence. So if I open a connection to the server saying, okay, I'm Firefox, I mainly speak French, but I can also speak English and Japanese or whatever you want. I prefer to have HTML, JPEG, GIF, or JSON, but if you have some PDF, I'm fine. I'm working on the host name of twitter.com, blah, 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 blah. All these headers, based on the beginning of the connection, will be persistent for all the stream. And for each stream, I can add optional header saying, this stream is to getting an image. This stream wants Japanese only language. This stream is about to give you, I don't know, this kind of authentication just for this stream and just for this request inside the connection. It's very interesting because what we can do now is authenticated all the assets management. So before, we don't want to authenticate people on assets because it was a huge lack of time, so we put it on another domain name to just be able to open new connection without cookie. Right now, what we can do is just to be sure that all the connection will be with the user authentication, because what is the user authentication is the connection himself and not only the request, the stream. Okay? I am clear on that. So it's basically quite interesting because all the header will be bring another level of contextual information between the header persistence and the new hashpack system. It's a lot focus on web performances, and it's very good, and we are all happy with that. The problem we have is we cannot say the URL of all the country on all the website will be changed. It's impossible. So how can we update the web? We cannot say, okay, in 1 week you will be, okay, we will all be on HTTP2 in 1 week. We just set up a maintenance for all the internet. We can't do that. So the problem we have is how we can move from HTTP1 to HTTP2. And when I say HTTP, I want to say HTTP and HTTP secured. So there is a way to negotiate a protocol elevation. So that's why I was talking about in my talk yesterday about protocol. One thing important about protocol is how to negotiate the thing about we have to move from one protocol level to another. In fact, HTTP1 was thinking about that, and there is a built-in method. The built-in method in HTTP is a header called upgrade. If I send a request and I think the server is able to deliver a new protocol version for something in an upgrade header, I say, okay, I want to go on this protocol. And the server answers the code 101 switching to say we switch off protocol. This workflow is basically the workflow of WebSocket. WebSocket is doing exactly that. Is unchecking with the server with an upgrade headers, and the connection is open thing switching, and then we are on the WebSocket protocol, which is on top of HTTP, but an upgrading thing on top of HTTP. Okay? The problem with that, it's working very well, and it's the way we will be using HTTP2 in just HTTP way. The problem with that, it's still slow. Why? Because if you open a first HTTP one request and the server say, okay, I'm able to speak HTTP2, let's switch, and then I ask something in HTTP2, you see there is a handshaking quite slow. This is a problem. Let's think about anything else. TLS. Today, we all know that we are moving to just secure all the web layer to HTTPS. There is people like let's encrypt and a lot of things saying we will bring a new level of security around all the web, and it's TLS. And actually, all the system is working on a negotiation system. So basically TLS saying, okay, I'm TLS version 2, 3, 1, whatever, and I'm able to speak with this. And what is a cipher? The cipher is the algorithm used to encrypt the data. And I am able to do other things. And the server said, okay, we will use this version of TLS or SSL on anything with this cipher, and the conversation begins. So there is a negotiation actually existing when you are speaking in HTTPS level. The working group have decided to negotiate the protocol in the same time of the TLS, because there is a negotiation, so we will negotiate TLS, cipher, and HTTP level at this kind of connection, which is pretty interesting. This is the way Speedy was working. Speedy was using something called NPN. For various reasons, NPN lets decide at the end what will be the protocol by the client. And for the other reason, RLPN is the decision of the server, and RLPN is the version we will use with HTTP2. So basically, we are able to negotiate an elevation of protocol to HTTP2 in the handshaking of security level. So we will bring down the first handshaking at HTTP, which is more faster. It's a good news. The other news about that is today, Firefox and Chrome have decided that they will not implement HTTP2 without SSL. So in fact, if you want to use HTTP2 with these two browsers, you need to use SSL and LPN negotiation. So people asking me a lot, like, is it for real? Anu, are you not telling me an IPv6 story? Who knows the IPv6 story? So, it's sad. We all know we have to move forward to IPv6, but it's quite complicated. I don't think it's a IPv6 story, because first there is the Speedy experience. When Google launched Speedy, it built it in Chrome, then Firefox followed, and Internet Explorer, and everywhere. And there is about something like 20 to 30% of the web today served by Speedy. So basically, we know major websites with a huge traffic want to use Speedy. And the thing is, there is some reason. Okay, it will be benchmark time. Benchmarks are benchmarks, which is basically not the truth. And we all know that. But it's a big picture. This is the Speedy implementation at Twitter. In blue one, you have HTTP, and in green, you have Speedy. And this is the latency of the request on top of Twitter. And we can see it's a huge availability of low latency system for the user. So Twitter switched to Speedy only for this. And this is why quite interesting. About HTTP2, it's quite impressive. This is one of the implementation of HTTP2 called H2O. H2O performances are on blue, and the red one is Nginx. We all know that Nginx is a pretty fast browser server, but the thing is, H2O is just faster. This is, I will detail all the statistics because it's complicated to read. In the blue you have H2O, in the red you have Nginx, and it's a number of requests per second, so bigger it's better. The thing is, on the top is HTTP 1, then HTTP 1 with security level, and this is HTTP 2 with security. Okay? It brings a lot of attention there because it's way faster than what we can do with HTTP 1. And this is the point. HTTP 2 is so performance-oriented that we all know that major website will bring majority of the traffic in the internet will adopt this quickly. And all the browsers are on the table, so it's available and activated by default in Firefox and Chrome. Curl have improved this. Internet Explorer will ship a draft of HTTP like in a few weeks, or maybe it's already available. And you can try it on Google, Twitter, Akamai, and all this kind of thing. You have, this is a URL for tracking the implementation of HTTP 2. So, yes, it's for real. We will all use HTTP 2 like this year for everyone in the room, and sometime without knowing it, because it's already there. It's good news. What is the Clever Cloud point of view about that? At Clever Cloud, we have a lot to think about how developer will manage this, because all the framework out there will take a lot of time to manage the problem of HTTP 2, because there is two levels of support of HTTP 2. The first level of support is saying, okay, my HTTP server, parser, whatever else, is able to deliver HTTP 2 connection level. The second level is to bring to the developer API to bring HTTP 2 feature inside their application, because you have to think new API to say, okay, how to pre-populate caching system, how to manage stream priority, and it can be done like programmatically, and you have to implement HTTP 2, but also implement new kind of API and new kind of way to interact with your application as a developer to bring this to the people. It will take a long time. It's a very hard work. So this is what we are working on Clever Cloud. We are building a new reverse proxy, which is very cool, and it's there. It's written with Rust, and when the client is able to speak HTTP 2, the reverse proxy will improve the connection to HTTP 2 and speaking to your own application with HTTP 1 with permanent TCP connection inside the platform. Early benchmark we did give a 10 to 15 performance gain with no code change, which is pretty huge. And it's all the goodness with HTTP 2 in your HTTP 1 application for nothing. So basically, why HTTP 2 is so cool? It's a huge performance check. It's remove all the shitty acts we do all the time in HTTP 1 to improve performances or feature, and it remove all the acts on security too, because it's binary, it's safer. There is a lot of things more safer in HTTP 2, and this is cool. And it explores new possibility. Remember, we have HTTP 1 for 20 years, and we're building Comet application for about 7 to 8 years. So with a brand new protocol on this layer, we will bring invented a lot of new things in the years to come, and this new thing will improve the user experience, which is pretty cool. So I'm very happy of the change. This is my to-do list. Just go on http2.github.io. Here is the home of the specification, of the implementation, the question, All the news, all is there. You can hack around HTTP2 with JT, H2O, Node.js, and it's quite simple. And if you haven't, just install Wireshark on your laptop, not only for HTTP2, but also when you are debugging your application, your HTTP1, RC, mail, whatever it can be, because it's a very good technology and it's far better than just hanging in the browser console. So, thank you very much for listening to me. Give it a try to Clever Cloud, and this is question time. Thank you. Yeah, I think. Do we have a microphone for the question?
No.
Okay.
Try it out. You mentioned that it's hard to transmit the binary data with a text protocol. Why is that? Because text is also binary. You can transform it to binary.
Yeah, sure.
You can represent all the text with binary.
So the question for everyone listening, the question is why it's hard to transmit binary data with a text protocol? Because you have to layer your binary data into the text protocol, because the text is binary, but the binary is not text, and you have to move your binary thing on top of a layer which is higher. So it's kind of complicated, and it's happened in a huge spaghetti plate. So this is why it's not cool, in fact. At the beginning it seems cool because you're just opening a socket and speaking to the server. Yeah, it's so cool. But the thing is, after all, you have to make parsing all the performance choice, which is quite complicated. And if you are in a text protocol, how you can define something is boundaries. And this is why there is a lot of complication when you're doing all the thing, and this is why multi-port requests are such a huge complicated things, because it's happening on the text layer. And if you're thinking about it, text layer is higher than the binary layer. So let's stick to the binary layer, and we can forward text on top of it. And the other way, it's quite complicated. Yeah.
Can you add new headers, your custom headers to request?
Sorry, I doesn't listen.
Can you use your own custom headers in HTTP?
Yeah, the question is, can you use your own custom header in a HTTP2 request? Yeah, sure. It's basically the same meaning than the HTTP1 specification. So you can extend on verb and on headers the same way, because it was so cool on HTTP1. They don't scale the protocol at this level. Yeah, sure. You can use it at this level. Yeah, sure. Any other question? Yeah, sure.
You were talking about the more streams at the same time. Are they running through the same port? Or how are they separated each from other?
So, the question is about there is many streams at the same times, and are they running at the same port? Yes, because what we call streams is only a way to pack data together, to say this is a pack of data coming from this request, this thing you ask, this stream. So basically, there is only one TCP connection, and all the data is put on this. One piece of data behind another. But the thing interesting is, if the connection is quite huge, we can put all the huge stock of data inside the string and have huge frame. So basically, it's not a lack of performance. It's a better way to have performance, in fact. So.
Actually, two. So we mentioned WebSockets, and you mentioned that in HTTP2, the server can send a cache to the browser.
Yeah.
Is there any other way, implement the WebSockets functionality so that the browser, the server can initiate the communication to the browser? Maybe not initiate, but send events to the browser. And the other question is, if you see any downsides of the HTTP2, and anything that's not as you think it should be.
Okay, so the first question is about if there a way for the server to send event to the browser. In fact, yes, because if the browser is requesting, I don't know, for example, a JSON from the server, and the browser is knowing that the JSON is not a static resources, but a dynamic resources with a stream, the first frame of the data coming from the server to the browser will be an event, and the second stream will be another event. And as the HTTP2 connection between the two is never cut, you can have server sent event whatever you want, because in fact it's built-in in the protocol. The protocol is made for that.
Okay, but I'm just wondering how you interact on the browser side. Is it like WebSocket or is it something?
It's something new. And I think browser will be handling a new way to manage it like very easily. Donc, I think there will be new browser API for handling that. But in fact, it's built in the core of the protocol. The core of the protocol saying maybe a resources, a stream, cannot be finished. Maybe it's just a stream of data with more data to come. And this is the way the browser will think about it. So basically, you can have server-sent event or maybe WebSocket, because the browser can ask for new things and the server launch some new things. So it will be more like cleaner than WebSocket, which is basically quite complicated to understand, and it will be faster. So it's built in on the protocol. And about the downside of HTTP2, yeah, there is downside of HTTP2, which is we can bring this in way further more things, because HTTP can be extended in many ways. But the thing interesting is HTTP2 have a better negotiation of next protocol. And the other thing is, in 20 years we use HTTP1, now we have HTTP2. It will like clear the head of developers about always using the same version of HTTP. So there will be an HTTP3 at some point, I don't know when, but it will be a correction of what is not good on HTTP2 at some points, but it will be easier to do because the people are not stuck on the same thing, and the base of HTTP2 is far better because it's binary, because there is protocol negotiation in the head of the thing, because there is compression. The compression is built in on HTTP2 too. So there is a lot of things like this you can do on HTTP2. There was impossible in HTTP1. So it will be more extendable and more evolvable to a future HTTP3 if it's needed at some point. So I don't see a done way to HTTP2 at this point. The only problem I see for the implementation is about HTTPS and the necessity of a certificate to have an HTTPS connection system inside your browser. But at some point, you have to secure the web, and I think the browser decision it's kind of acceptable. So it will bring a lot of power to do that, and it will be a huge change inside the certification market, but at some point it will be a better web. So I think in the next year or maybe the next 2 years, this problem will be vanished. So.
Just one more question, if I may. Again, so I was wondering also about performance, because you need to keep the connection open, and for the server, the connection open with all the browsers that know the connected, and user of not, do anything else in the website, just look at it.
So the problem is, the question is about how to manage performances, because all the server have to manage a lot of connection open with browser. How we can manage this? First thing, if the server at this side, you have given to the browser all you have to give to the browser, you can cut the connection saying, goodbye, I have give you what you need, and I don't need the connection anymore. You stuck the connection because you know you will have some more exchange. The other thing about that is today browsers are handling a lot of connection because of the HTTP pipelining. So we're basically using 5 to 10 to 20, maybe in some point 30 connection to the same server to just managing all the thing, and we don't know what we're doing with all this kind of connection. So servers are managing a lot of connection. And the last point is TCP long-term connection are not very expensive. Every people are thinking about TCP connection as expensive. You think about it, all the push notification system of this kind of thing are just TCP long-term connection. So it's not so expensive to do that. Okay, there is a little bit trick on the server side about the TCP long-term connection of push notification. But this kind of trick can be built inside an HTTP2 server. So basically, it will be better on the time to have this kind of thing. So I think it's not a problem of performances. It will improve the performances at a global level. Any question? No more question?
Yeah, you said about the possibility to lower the quality if the connection is poor.
Yeah.
And I understood that the server will decide that the quality can be lowered. But what if I am on my mobile device and the quality is low, and I still want the picture to be sent in the best quality to save it locally?
Yeah, the question is about how to manage quality and how to manage this. It's the decision of the browser and the server at an application level. I say it's a possibility to send a bad quality picture to improve the performance of your website, but you have to code this because it's not built in on the server right now. You have to re-encode images. You have to make decision about, okay, I think the quality of the connection is this. If the quality of the connection is so bad, I have to change the quality of the picture and things like that. You have to make all the decision and code this. If you want to code a button inside your application saying, I want all in high quality, it's not a problem. You can just call this button to deactivate this part of your code. It's just ability, a new feature introducing by the protocol. You can use it, but you haven't to use it. It's your choice to make. Before, you cannot do that. Now you can. It's your choice to make or not this kind of feature for your application.
So how will my application know that now the quality is lower and lower the quality of?
The application know it by statistically measure what is the bit rate with the client. You can. Yeah, your application has to do that. When I say it will take a huge time to gain all the benefits, all the good part of HTTP2 inside real application, I'm serious. There is a lot of work to do to bring all the ability of HTTP2 to the next level, because this kind of thing take a huge time to manage new picture server able to negotiate the bit rate with the client and say, okay, we have to do this that way. So it's a little bit of work, yeah. Yeah, and it's a protocol. It's not like you can or you cannot do using it, but the protocol gives you the possibility to do it that HTTP1 cannot give you. If you want to do it, it's not a problem to do it, but it's not an obligation. By default, the protocol is just a protocol. You have to make the implementation on your side. This is why benchmarking is something like, yeah, we're serving static file, okay. What is impressive is a big picture of the new feature improved by the protocol. If you want, I have some cool stickers of Clever Cloud there. Is there any question? No? So cool. And I finish in time. I'm so happy. Thank you very much for listening, and get back some stickers.